All right, good morning, everyone. Welcome to Quarantine Statistics for March 30th. Now, at the end of last week, we started working with logarithmic problems and not only setting up those data sets, but actually solving for values of x or y, depending on the context of the problem. So, since I didn't include any more logarithmic problems in your actual packet, what I've done is I've brought up a logarithmic data set and a couple questions here for us to work out. So what you'll see on the screen here, it has a question that says an app creator tracked the sales of his app for the first 14 days after it was released. Since the sales slowed over time, a logarithmic model could be used for the data. So I think this is a very realistic data set. You know, whenever we talk about what our relationships are going to be logarithmic, I think you could do this for just about any sort of item that has gone on sale, whether it be an app, a video game, a book, whatever this may be. Whenever you have something that releases, it has that big boom in sales, that exponential growth. If you look at, how many people own this after day one, and then day two and day three, it's really high. But after a while, those new objects or apps or whatever they are, kind of diminish in excitement, and their growth starts to slow down a lot, creating that logarithmic model. So what I've done is I've put this data set in. Now you can do it on your calculator, but there's actually a website you can do this too. What I did is I just Google searched a logarithmic regression calculator, and it's on this Keeson online calculator. If I'm saying that right, I may not be, but you guys can go use this if you don't want to use the calculator, or if you don't have a calculator, something like that. So you'll notice I was able to put in all the data here, day 1 through 14 in the X column, and then the total number of app downloads in the Y column. And what I can actually do is click the execute button right below it, and that will calculate the values of A and B, the correlation coefficient, and it will actually graph the scatter plot for me as well. So you can see here in this graph that is very much a logarithmic model. And it looks like that line of best fit fits it very nicely. It has a correlation coefficient of 0.99. So, I mean, we are looking good across the board here for this being an accurate representation of logarithmic regression. Now, we also get a value of A of 269.6, or round up to 270, and a value of B of 434. So, if you recall, the equation for a logarithmic regression is y equals a plus b times the natural logarithm of x. So what this would look like is y equals 270 plus 434 ln x, or the natural times the natural logarithm of x. So I'm going to go back over to the original question, see if we have one of these that matches that pretty well, and we do. A here is exactly what we were looking for. They rounded it to the tenths. That's perfectly fine. So we see our equation there. So that's the answer to our first part of this question. Now we have a second part here that says predict the total number of sales after 4 weeks. Well, that's going to be simple enough. We can take this equation and plug in what we need, what we need to. So if we're looking at 4 weeks, then we're looking at a metric of time, right? And the x value measures time, the y value measures the number of sales. So we're going to be plugging in something for x here. Now the question is, what do we plug in for x? Is it 4, or is it something different? Now you may realize that it's important we look at our units here, because this is for 4 weeks, and our x value is currently being measured in days. So we have to make sure we do that conversion. So 4 weeks in days, or 4 times 27, is actually going to be on day 28. Now, with a calculation like this, this calculator doesn't do it for you, but Your calculators that you should have at home, or to be honest, just about any phone calculator should be able to do this for you. So I'm going to go ahead and do that on mine, and then I'll write that up here. So 269.6 plus 434.5 times the natural logarithm of 28 will get us 1,117. So we find out that y here is equal to 1,717 total downloads. All right, so I know that's the last problem that it really asked us for here, but we are going to do one other one. I'm going to create one last one, and my question will be, on what day will we see the app reach 2,000 downloads? So when we ask ourselves, where do we put this number? Where do we put the 2,000? Well, again, the x value represents the number of days. The y value represents the total number of sales. So then, if we're looking for the day when it reaches 2,000 sales, then we're going to replace y with 2,000. So we're going to have 2,000 equals 269.9 plus 434.5 ln x. And if you recall from the video Friday, I like keeping this ln x just in one big set of parentheses to remind myself that I need to get that on its own as an entire unit, and that this has to stay with it until the very end of the problem. So to do this, we again have two different things we have to move. We have to move this 469.9 and this 434.5. We want to get rid of the 269 first because it is adding or subtracting, and that's going to come first in our, opposite order of operations, as I like to call it. So we get 2,000 minus 269.9, which gets us 1,730.1. And then that's going to leave us with the 434.5 ln x. Since the 434.5 is multiplying the logarithm, we are going to go ahead and divide it out. And 1,730.1 divided by 434.5 is going to get us approximately 3.98. Ooh, that was not a pretty 8. I apologize. Writing on a screen with your mouse, believe it or not, is not the simplest thing I have ever done in my life. So we went over exactly how to solve this final step of the problem, and we did several examples of it on Friday. So if you need a refresher on that, I would recommend checking out Friday's video. But long story short, what we do here is we take this from being written in logarithmic form, since a logarithm is in here, and write it in exponential form. And the way to write this in exponential form is to remove the logarithm. I can change colors on this thing. Oh, I should have been doing that the whole time. Nice, look at that. Canceling that number out, canceling those numbers out. Oh, should have been doing that a long time ago. Anyway, we cancel out the natural logarithm. We replace it with an e to the power of our current answer. So that logarithm gets replaced with an e, otherwise known as Euler's number. It's a constant that can be found on your calculator, whether it be a fancy calculator you checked out from me or just your phone calculator, whatever. And that equals x. So effectively, we pick up that natural logarithm, we take it away from the x, and we put it over here in the form of an e. So we write in e to the 3.98 power, and we end up with 53.5. So e to the 3.98 is 53.5, which, since we're talking about a number of days, we would very likely just round up to 54, but we would find out it would be 54 days, or a little over 53, to get this app to a total of 2,000 downloads. So this is the process of logarithms, graphing, calculating, finding some variables, all that. If you have any questions about it, let me know. There's no other questions in your packet about logarithms, so I don't have any further ones for you to try out now. But if you are interested in just trying some to test your ability, to learn for yourself, that kind of thing, you can very likely find some just by Google searching, logarithm worksheet problems or logarithmic regression problems. But with that, I will see you guys tomorrow.